So, alright, guys, welcome you back to this last session on this motion chapter, guys. So, here basically we have covered up all important stuffs related to what is motion, the types of motion, and different equations of motion. In fact, we had a talk about the graphs involved in the motion, and finally, the equations of motion as well. Right. So, we have only very small part left in this motion to be covered up. So, let us move ahead today to explore all about uniform circular motion, guys. So basically, before heading on, what is circular motion? Let's check out that, guys. So guys, any object which moves in circular orbit, that is generally we call it as circular motion. But guys, what is the common phenomena by which this object is able to move in a circular orbit? So you can observe here in this situation as the man is moving this stone, let's say attached to a rope in horizontal circle. This is horizontal circle. So what is observed here? A force is applied tangentially and there is a force which is acting towards the center. So guys, this force acting towards the center, we call it as centripetal force, right? We call it as centripetal force, and guys, this is the only force which is responsible for circular motion. Because guys, generally what we know, whatever is the direction of the force applied, the object moves in that direction. So here, if only this force would have been there, then the object would have been moved in this manner, in this direction. But to restrict its motion along this tangential direction, there is a centripetal force here which is acting towards the center, and due to this, the path is curved. Right. So let us move ahead and let us look upon the different forces that comes into picture while we talk about the circular motion, guys. Right. So we have the two forces here, centripetal force as well as centrifugal force. There's one thing you have to remember that the centripetal force, it's real force, and this is a kind of ideal force, or you can say it's a kind of hypothetical or imaginary force, right? But guys, what is centripetal force? Let's define that. It is that force which is acting towards the center. It acts towards the center when object moves in circular path. When object moves in circular path. So guys, one thing we can say that the centripetal force, it is only the force that is responsible for circular motion of the object. It is only responsible for circular motion of object, right? So guys, what is the centrifugal force? What is the concept behind this? So it will become more clear, guys, when you go through the forces and laws of motion. That is the part of our next unit, guys. So stay tuned. We will be exploring all about the forces first and then all about the centrifugal force. But in short, I'll just give you a small introduction about what is centrifugal force. So when this object is revolving in this circular manner, there is a force acting towards the center, that is centrifugal force, centripetal force, CPI. So that force is towards the center, and centrifugal force, it is absolutely opposite to the direction of the centripetal force, that is centrifugal force, right? So as of now, understanding about centrifugal force, this much is more than enough. Later on, I will just cover out, guys, all about the forces and laws of motion, and then we will again go through the centrifugal force, right, guys? So guys, let us now understand the concept of distance and displacement in circular motion. So guys, we have already discussed that if an object moves in circular manner, so let us say object starts at this point A, and after covering this circular path, it returns back to this A. Then we will have the displacement to be 0 because initial and final positions coincide, and the distance definitely will be equal to the circumference, that is given by 2 pi r, right? R is the radius of the circular path. Same way, we can just find out the speed and velocity. Only thing is that for speed, we will require the distance that the object has moved while covering the circular path and divide by time. And for finding velocity, we can just divide displacement with time. Okay, guys. So let us just move ahead to a very small question that we have from circular motion here. In fact, an artificial satellite, it's moving in a circular orbit. So guys, whenever we observe this term circular, we have to just make our mind that it's all about circular motion. And here the radius, it's given as 42250 kilometers. What is the time it takes to revolve around the Earth? That is 24 hours. So guys, this is an artificial satellite. So let's say this is Earth. So this is an artificial satellite and it's revolving around Earth. So what is the time taken to revolve? 24 hours. What is the radius of the circular orbit or circular path in which the satellite is moving? That is r. So guys, here we need to find out the speed. Let's write down the formula for speed, that is distance over time. And what is the distance, guys? It is 2 pi r. That is the circumference of this circular path over time, t. So what is 2 pi r, guys? 2 into 3.14 into radius, that is 42250, and we'll divide it by 24, and that should give us, guys, 11055, and the unit will be kilometers per hour, right? Okay, so let's move on to the next question. So here, guys, you all are advised to just pause this video and try it on your own, and later on you can just compare your results. Okay, so here a boy moves along the circular path of radius 7 meters. So let's say this is the circular path, the radius is 7 meters. You have to find out the distance and displacement if the boy covers 1/4 of the circular path. So let's suppose the boy is starting at this position A and it has moved to B, because it's written that the boy covers 1/4 and this is the 1/4, right? So what will be the distance, guys? It will be this curved path from A to B, and that will be 2 pi r over 4. Guys, why I'm dividing this by 4? Because in the question it's clearly mentioned that we have to find out the distance boy has covered in 1/4 of the circular path, right? And to find out the displacement, we will need to join this line, join these points A and B by a straight line. And this yellow line shown here, that represents the displacement. So guys, we can make the use of Pythagoras theorem, and in this right angle triangle, what is this hypotenuse? It is square root of 7 square plus 7 square. That gives us 7 root 2 meters, right? Very simple, guys. So let us just summarize what we have gone through in today's session. Basically, we talked about the circular motion, and an object is said to be moving in circular orbit if there is centripetal force acting towards the center, right? So if there is centripetal force, then only object will be moving in circular motion, else the object cannot move in circular motion. Okay? Yes. So all right, guys. If you have any queries or any doubts, you can feel free to mail your queries or doubts on rashmi030295@gmail.com, or you can even comment your questions through the comment box. All right. Okay, guys. See you in the next lecture, whereby we will be exploring and starting new unit, that is forces and laws of motion. All right.